Now we are going to start with another property, that is the reaction towards acids and base. So just to recall, we know that boron 13 group family is boron, aluminium, gallium, indium and thallium. So what we are going to do is, we are going to react them with acids as well as we will show a reaction with base also. So what we have seen, first we will start with an acid. What we have seen that boron doesn't react with non-oxidizing acids. That means the acids which are lacking oxygen in them, they are actually non-oxidizing, like HCl, HBr. So it doesn't show a kind of reaction with the non-oxidizing acid. But with an oxidizing, it shows a reaction like we have boron, right? So we'll have a mixture of oxidizing acid, that is HNO3 with H2SO4 present in ratio 3:1. So we are going to react with it. So we have HNO3, H2SO4, we'll heat it. So what we'll see that when it reacts with an oxidizing acid, so it gets oxidized and it forms its respective acid, that is the boric acid. So what is the formula for boric acid? It is H3BO3, and along with that you get to see nitrogen dioxide, that is reddish brown gas, that is NO2. And if we so that means it's clear that boron doesn't react with non-oxidizing, but it reacts with oxidizing acids. But as we talk about the other members like gallium, indium and thallium, so what we see that all of them react with oxidizing as well as non-oxidizing acid. But we have seen an exception in case of aluminium, that when aluminium react with concentrated HNO3, you know that concentrated HNO3 is a powerful oxidizing agent, so it oxidizes aluminium to Al2O3, right? Along with that we get NO2 also and H2O also. So what we see that this Al2O3, as we have already discussed, that this layer doesn't allow the you can say that it is an impermeable layer, so it actually prevents the further aluminium in reacting with the another substance. So let's say that this is aluminium, right, and here we are going to pour HNO3, so it is going to form a layer on its surface of aluminium oxide which is impermeable to anything. So that means it will further prevent the further aluminium in reacting with the concentrated HNO3. So we'll say that after some time the reaction actually become passive, or aluminium become passive. That means it doesn't react due to formation of this thin layer of Al2O3, which then just stop the reaction, right? Now coming on to the action with alkalis, what we have seen that when we react them with alkali, the reaction up to 773 Kelvin is okay, that means they form the respective hydroxide, but above that they form their salts like boron. If we talk about boron, it form borates and hydrogen gas. Let's show in reaction. This is our boron, right? We are going to react with an alkali. Let's say we'll take a caustic soda, that is NaOH. So it is going to form its borate, that is NaBO2, that means sodium metaborate, and along with that we will see a hydrogen gas also. And in the same way, boron is going to react with NaOH, it can form NaBO2 also, and it can form Na3BO3 metaborate also, because this is a metaborate. But what we will see in this reaction, that means up to temperature 773 it forms the sodium borate, not metaborate, that is Na3BO3. Likewise, if it react with caustic potash, that is KOH, it is again going to form its borate, that is our formula K3BO3, and along with that we get a gas which produce a popping sound, we all are familiar, that is the H2 gas. So this is how they react with acid and alkalis. I think you got it, that with acid you need to remember boron do not react with non-oxidizing but react with oxidizing, and it give rise to its boric acid. And all other elements otherwise react with oxidizing or non-oxidizing. Aluminium react with concentrated HNO3, but after some time it becomes passive. You know that due to formation of this impermeable layer. And with alkalis, typically if we talk about boron, then it forms its borates, like with sodium it is forming sodium borate, with potassium it is forming potassium borate. So that means boron actually with alkalis form its respective borates and hydrogen gas. So this is all about the reaction of 13 group elements towards acids and bases.